of the day. And it's not about my keynote. It's about the people, what you will see and hear the ideas today. These are the ideas which are making India and making the world. So thank you everyone for being with us, and I really have to thank the entire judges who have taken time to be with us. I think Shraddha is going to be joining us shortly. But truly, just imagine, started in October, 2,500 plus applications and ideas. And frankly, to my mind, each one of them is a winner. We will actually be following up with all of them to see how we can work with them. There are certain aspects on which I think the jury will be looking at it. Keep me out, this is going to be the most difficult job today. But it's not just the 20 who will be today looked at in a different manner where the numbers are given out. But I think we would look to work with each one of you in this effort. And what we are now witnessing is a new beginning of a new world in many ways. And the makers of that new world are sitting in this room today and will be presenting to you. So I will be short. Today the day belongs to all of you. So we'll be waiting to see and learn from all the ideas which you're bringing to us. Thank you.
Thank you, sir, for your motivational address. On that note, we would now proceed to the finale presentations without much ado. The 20 teams that will be presenting today have been organized in 6 panels of 3 to 4 teams per panel. These panels have been curated according to the themes of the solution, ranging from healthcare, assistive technology, to road safety. Each team will have only 5 minutes to present. Teams, please note, a buzzer will be played at the end of your 5-minute timeline. We request you to adhere to the timing guidelines. Exceeding time limits may attract penalties. I would now like to invite the first team of panel 1, UI 14258, to please come forward and make their presentation.
Audio is working, right? In the presentation.
You have it.
Yes.
Tech team, please can provide support.
Audio tech check would be really helpful.
It's here. It's not presenting. Okay, it's here.
Audio काम कर रहे हैं? हाँ, audio. Thank you. I can take the mic. Okay. I'll just speak like this. I can start? Okay. Hello everyone. I am Praneeth, founder of Paraspeak. Listen carefully. Okay. So the audio was only on the laptop in this case, or?
We'll wait, don't worry.
We'll wait? Thank you.
Just fix this for him, please.
Thank you so much.
Can you put this mic closer to the speaker?
Understood.
Try with that. Move the mic.
The PPT has closed.
Just try it once or twice.
That's alright. I also brought some speakers in case that would be a problem.
There's no rush. Just relax.
अगला दवाई आ जाएगा. Did you understand? Anyone? Neither did I 1.5 years ago. Over 650 million people worldwide face voice and speech disorders caused by conditions like stroke, paralysis, Parkinson's, and more. I started with dysarthria and presbyphonia, conditions that remain largely underserved. The question is, can we enable a full range of communication for these people by converting their impaired speech into clear speech? Existing solutions are speaker dependent, English only, and inaccessible to those who need them most in both cost and form factor. Introducing Paraspeak, a pocket-sized device that can convert impaired speech into clear speech on a real-time basis. Remember the voice in the beginning? That person had dysarthria, a devastating motor speech disorder causing slurred speech. Let's hear what they were actually trying to say.
आपको मनपसंद रंग क्या?
It feels incredible to see someone so happy to hear their voice back in a way everyone can understand. So, how does it work? Press the button and speak. The speech is then processed by advanced cloud-based AI models. Building these models was a long journey, from collecting the largest database of Hindi dysarthric or slurred speech to creating a high-accuracy framework that works even with limited data. Then, clear speech is played back on a near real-time basis. This framework is patent pending and Paraspeak is trademark pending. But there's more. My goal is to scale Paraspeak across many kinds of voice and speech disorders. Here's another demo with the same tech. This time, a patient with presbyphonia, where the voice weakens with age.
आप मेरी बात समझ रहे हो?
आप मेरी बात समझ रहे हो? Paraspeak is portable, affordable, India first, accessible, and designed to improve quality of life. My journey started 1.5 years ago in grade 10, when I went to a care center and met people who could speak but could not be understood. Then I got to work that won both national and international science awards representing Team India supported by the government. Paraspeak made the national news soon after. In October, I was selected to present at IIT Delhi's Empower Assist-Tech Research Conference as the only high school researcher. And recently, Paraspeak was named the national winner of Samsung Solve for Tomorrow with a seed grant from Samsung as well as an incubation at FITT IIT Delhi. Paraspeak currently stands at Technology Readiness Level 7 with extensive demos completed. Now, we have already launched a larger data collection program and are currently developing a market-ready version of Paraspeak software and hardware. By mid to late 2026, a clinical trial for CDSCO certification and other regulatory approvals will begin, and by early 2027, devices are planned to reach the market. I'm on a mission, bringing Paraspeak to those who need it most. Revenue will come from device sales, rupees 2,000 per unit, plus a rupees 200 monthly subscription. Paraspeak can also power public communication counters and other assistive devices through an API so that they can also understand impaired speech commands. Institutions, including government ones, can sign multi-year install and support deals. Alright. I have completed data collection and testing at 2 associated care centers, and I hold letters of interest from more institutions and neurologists, including over 100 people who signed up on the waitlist on my website. What Paraspeak needs is clinical partnerships, resources and funding, and a motivated team. I am ready to bring back the voice of those whose voice can't be understood. Let's embark on this journey together. Thank you.
For the entire panel, post 3 presentations. I now invite UI 9405 team to make the second presentation.
Is there a place to keep our laptops? Or no? I don't think there's.
I don't think there is. Do you need that? I'll just keep it here. I would need it for the presentation.
Ready? Keep connected.
Connected have to show. Yeah.
Yeah. All good? Ready? Okay. We've all seen elevator buttons with these random dots at the bottom. We know it's Braille and we know it's used by the visually impaired to read and write. But the one question we ask is how do they read it? The same question my partner Mania and I have been asking each other is कि ये पढ़ते कैसे हैं? Because there's not enough teaching force present in India teaching the visually impaired Braille. This is India's biggest education and market gap that we notice and we are here to fill in. Judges, we are WAVE. WAVE stands for Wearable Assistive for Your Vision, and we bring learning Braille to simple gestures. We are the first and only ones in the entire wearable assistive in India, and we are the first and only ones in the entire global market segment of Bharti Braille. Over here, as you can see, WAVE is a pair of wearable gloves which has 6 flex sensors in total to mimic a traditional Braille cell. This is our past prototype, and our latest prototype is as shown here.
This is our latest prototype here.
This is our latest prototype. It's ready to market, and as you can see in the images here, the faces are blurred out for ethical reasons. But we are already testing with multiple blind institutes, not just in Delhi but also in Kolkata, Lighthouse Kolkata and BRA DU. As you can see here, WAVE has 6 flex sensors to mimic a traditional Braille cell. And when I fold my finger, when I flex my finger, the voltage on these sensors fluctuates. This fluctuation is recognized as a gesture, which maps to my database of my alphabets. The database then moves to my website that teaches you entire Braille. As I mentioned, the biggest problem right now is the lack of teaching assets. For normal students, a teacher can use a lot of assets like YouTube video or other teaching assets. But for learning Braille, it's a lot more difficult. Of course, reading Braille is like so, but learning Braille requires a lot of one-to-one attention, which is not easy to pay for a class size of 30. And that is why we built WAVE that takes over the entire learning process of Braille. Not just that, but it also scales to a corporate setting. Right now, we'll give a quick demo. I request one of the jury members to volunteer for the demo.
Yes, of course. Also, do I have permission to blindfold you? Of course. That works. Okay. And what are we going to do? We are going to use.
As we prepare our esteemed jury member for the demo, I'd like to add that we have successfully filed our design and utility patent for India, and we are also building a Japanese Braille prototype with collaboration with the Japanese government for Japanese Braille. And this marks a significant landmark because we want to scale not just in India but overseas. Mani and I, we both come from a Middle Eastern background. She's from UAE and I'm from Bahrain. So we have a very solid network already built for Middle East. We are spread into the Southeast Asia, starting with Japan, but our first motive is to start with India. And as Adalji mentioned, we are made for Bharat and we are made in Bharat. So our first point of action is to build into Bharti Braille. And right now our prototype features Hindi, Tamil and Malayalam for Bharti Braille. Right now we'll quickly show the demo here.
Yes. Trust. All you have to do is listen to the interface and just do what it says. Okay. So ma'am, the interface is going to talk to you, and you have to just listen to what it says. This is what no problem. What about that? Okay, so now just keep it straight.
Can you just close it down?
Okay, I'm going to start. I'm going to connect the device now.
Can you flip the Mania?
Yeah.
Can you show the screen to the people? Maybe keep it.
That will be possible after
Possible? Okay. Oh yeah, that's the demo, yeah? Okay, I'll just wrap up.
Please select your language. Say English or Hindi.
So our website features 2 modes in total. There's learning mode and practice mode. In learning mode, the user learns alphabets from A to Z and numbers from 1 to 100. For every incorrect input, my website says, hold on, you're not exactly wrong, but if you make these changes, you'll be absolutely correct. This is very crucial because we are building something very...
Finger 5 is your right middle finger. Finger 6. Introduction complete. Your input will only be recorded after the 2 trigger beeps. We'll start with learning mode for letters A through Z. For A, bold 1.
So, firstly, this is
Not that you've heard of me. Finger 3 fighters. I just want you to go ahead and fold that. Exactly. Yes, just make it.
Bold 1 and 2.
So, you heard the vibrations, right? So, now hold both of them together.
For C, bold 1 and 4.
Okay, let's see what happens if she does it wrong. So, hold this only.
Your time is over. But finish your demonstration.
Okay, so now when she did it wrong, if you will tell me that it's wrong, we're going to do it again. So, let's say, what's the second word? Let's go to practice mode.
Switching to practice mode. Your word is cat. For C, bold 1 and 4.
Let it
Now just...
hold. Exactly.
So now we are showing a quick demo of our product. Here, Miss Reddy is trying it out, and you can see she's in practice mode. She's learning Braille right now, and we'll quickly show what the reports are if she needs some improvement in any of the finger mappings, which is very important for an instructor to know. The biggest gap in education right now is the teaching assets, which is what we cover. A supervisor or an instructor just needs to click a single button and we take over from there onwards. We teach, we give feedback, and the entire model is voice control. So you can give a voice command saying stop, start, or how am I doing? And it gives you a complete feedback of how you're doing and where exactly can you improve. Not just that, but it generates a complete comprehensive review of how you performed, where your mistakes lie, and where can you actually improve for the instructor to tell, कि हाँ मेरे बच्चे को यहाँ पे दिक्कत हो रही है. This is the best feature so far for the teacher's perspective, and we received a very good response from the teachers around. The BRADU and the Lighthouse in Kolkata, they are very eager to use our product, and we are already receiving orders for them. And I think...
Just to show the judges, we've also added a Hindi, so you add the Bharati. So there's learning and practice.
We'll close. When one sense is sabotaged, your other senses are enhanced. When your sense of vision is sabotaged, your sense of hearing, your sense of touch, and your ability of speech is enhanced. The same is utilized here as well. Your sense of hearing is utilized by adding a buzzer and an interface that talks to you constantly. Your sense of touch is utilized by adding a glove that gives you complete authority of control, and button vibrators that beep to nudge you using haptics. And lastly, your ability of speech is utilized by giving you a complete freedom of speech with the interface. You can speak in your mother tongue and it responds back to you. So this was Wave. And we are happy to announce that we have already filed our patent successfully, and we are building a prototype in Japanese Braille as well. Thank you. Oh, sorry. Yeah.
Thank you, team. Enthusiasm. Please, we shall all try to stick to the timelines so that all the 20 teams have a fair chance to present. Jury members, our third team is UI 3536. Unfortunately, they're still stuck in the security process. So we'll be moving to the fourth team for the next presentation, which is UI 13788. Technical team, please play the fourth presentation. 13788.
Hello. Am I audible? Yeah. Okay. Good afternoon all. Myself Aniket Karkelikar, and this is my teammate Nikhil Hegde. Imagine a consultation with your doctor where doctor is focusing directly on your patient. He's chatting with you, he's talking to you, he's reasoning well, and not going through all the documents that you are presenting to him, looking for the information that is specific to you. It's not just about imagination. That's what Arogya literally enables. So before understanding how it really works, let's understand the problem and the gap that is there. Today, the clinical expertise in the India is heavily concentrated in the metro cities. What remains in rural India is just a single doctor clinic where he has to manage everything from taking the notes to prescribing the medicines. But that creates multiple challenges. The doctor to ratio in the rural India is very high, and that gives us very less time for the doctor to talk with the patient. It's about 1 to 2 minutes. So what happens is doctor has to just react to whatever the patient is telling. And this problem cannot be really solved by adding more healthcare workers, because healthcare workers with time tend to move towards the tier 1 cities only for better pay and better lifestyle. So the only solution to this problem is how do we really empower the ones that are really on ground in the rural India. And to solve that thing, we are creating Arogya AI. But in this, India's digital public infrastructure, as well as the policies are very interesting and they are very aligned at this time right now. India has built ABDM, the Ayushman Bharat Digital Mission, which really has digitalized around 80 crore ABHA health IDs and digitalized 67 crores of health records. And with time, in 1 to 1.5 years, in states like Maharashtra or Tamil Nadu, the adoption of these health records, digital ABHA, will be very high. But there is still a gap. There are solutions like Ekacare, HeyDoc, which are really doing digitization of the documents. But the gap is, if we just digitize all those documents and dump it to them on the laptop, firstly, they don't tend to use new tools. And if we give them that in digital form instead of paper, there is no use. So there is a gap, there is a need of a system that can reason over all of this data and present to the doctor. And exactly that system is Arogya AI. During our discussions with the doctors, we noticed something really interesting. Specialist setups, there are juniors and assistants that are helping the doctors. So before even you enter the cabin of the patient, you have already gone through 2 to 3 cabin of juniors where you have been done the preliminary assessment and everything. And on paper, the specialist just sees whole case and the thing that is suggested by the juniors, he just revises some things and suggests them. Our vision with Arogya AI is that one doctor plus the system that we are building with Arogya AI should be really equivalent to the reasoning capacity of entire specialist setup. Let's just see that in action.
Before the consultation even begins, Arogya AI Before the consultation even begins, Arogya AI captures the patient's concern in natural language and structures it automatically, so the doctor's time is spent on decisions, not data collection. Within seconds, the doctor sees a clear clinical overview of the case. Every insight is backed by complete reasoning, evidence, and traceable sources. The doctor interacts naturally, asking questions, exploring context, and guiding the system. Prescriptions and investigations are generated instantly and delivered securely to the patient through ABDM.
At first, when we showed this idea to the doctors, they were really skeptical and they thought, will this really work? But after showing this UI demonstration, they were like, if implemented correctly, then this can really solve a lot of problems that they face every single day. So, Arogya is built on 3 primary pillars, that is ABDM native, SLMs and evidence-based RAG. So our system is already has ABDM integrations, and based on the consent of the patient, we plug in the data into our systems. We have specialized SLM models so that we can scale to across the country, also to the rural places of our country. So evidence-based RAG helps the system to answer based on the facts and not just on the base knowledge. So with Arogya AI, early diagnosis becomes the default, not a privilege. If preventable deaths become treatable conditions, because every doctor everywhere reasons with specialist clinical intelligence. Hence, we work for welfare for all, happiness for all. Thank you.
Thank you, teams. Jury members, we are open for the query.
Where are you from? I am from Maharashtra, Latur district.
Can you just speak
You guys have a demo? Do you have a demo?
Yeah, we have a demonstration, but we avoided it because of the time constraint.
I would like to see that demo.
Yeah.
Jury members, we are open for queries. So for the 3 teams that have presented, in case there are any further questions to the teams, please feel free.
Testing, yeah. So one just phenomenal to see the clarity of both the problem identification as well as the innovation that you're applying. I guess my question is for me, starting with the first presentation, Paris. Paris Way. So I guess 2 things. One is there was a little bit, I know you said it's real-time translation, but there was a bit of there was a time lag. I'm curious how you think about closing that time lag. That's 1. 2, what was the hardest challenge in solving the problem?
So, for number 1, currently the AI server, which the model I've built is running on my laptop as a server. So the hardware device communicates with my laptop, which then clarifies the speech and sends it back. But in a future deployment, and as most professional AI models are deployed, it will be put on the cloud. I've already tested it on AWS and Google Cloud. In both cases, the lag time has been reduced from around 5 seconds to 2 to 3 seconds. So once I deploy it over there finally, then even the device will be able to translate it pretty quickly. So the latency will be reduced. The second question. The hardest challenge I would say was, came with the hardware. So when I went to the care centers and repeatedly tested my prototypes, the feedback I got from the patients again and again took me through all of my prototyping iterations. So I definitely spent a lot of time on that, trying to create it in a very accessible manner, so that patients, even if half their body is paralyzed, they can still use the device properly.
Thank you.
I have a question for 13788. Yeah. Just tell me about, while I understand that this is those, more equipped for doctors who are in remote areas, likely, right? That's the proposition that you've made. When they are transferring data back, what kind of associations do they have with urban centers? The interpretation of the data. So what are there any particular urban centers they're sending it back to? Are there any healthcare networks that you are trying to tap into? And what is the specific connection or understanding between them? Because what I'm really talking about is how do you bridge a connection gap, if at all one exists?
So ma'am, this specific question we don't need to tackle. Government of India by NHA has already tackled this problem. They have built a full open source digital highway for the data of medical records by ABDM, Ayushman Bharat Digital Mission.
Okay.
So they are providing us the whole data, and whole data travels to their APIs to us. And it is based on the consent, like how we do in DigiYatra or DigiLocker, 7 days we get the access of the data. Same way it will be implemented in this system. And when pushing back to the patient, it goes back to again the ABDM, where it is logged into patient's ABDM account. And if he even goes to chains like Apollo, if Apollo is registered with ABDM, they can access that data. And if a primary clinic is there, they can also access the same data that is pushed by Apollo to the ABDM. But it depends that if Apollo will give that data or not, that's a different thing.
Okay. And this also should ensure patient privacy.
Yeah, for patient privacy, ABDM has already done something like redactions in name and all. What you get is just the primary pointers like A's, and it's like same like a case study, a textbook case study that we will get. The AI will process it via SLM in locally only. So what we are planning is using frameworks like Air LLM and all those things. It can be done on device like this if government provides a good type of infrastructure in the hospitals, that government hospitals. It can really be deployed fully locally, so data never comes to us only.
All right. Thank you.
Thank you.
And great presentation. All of you, all the three.
Thanks a lot.
Thank you.
Hi, I had one question for Paraspeak. What is the how varied and deep your data set is right now, what you're training it on, and how accurate is it right now?
So currently, over the past year, what I've been able to personally collect is about 45 minutes of data from 28 patients, and these patients have varied conditions from Parkinson's to paralysis to CP, congenital disorders and more. The in silico accuracy rate of my model is about 96.7%. I also conducted a real life pilot test with around 11 patients, and the accuracy in that pilot test varied between 80 to 95% depending on how severe their speech disorder is. Yeah.
Thank you.
And I have the exact same question for the second, 9405. On the accuracy.
Who? Raise your hand, please. Who wants to speak? Could you repeat the question once?
Yeah, no, it's the same question about the accuracy of the model.
Yes. So we tested with around more than 120 students, not just in Delhi but also in Kolkata, and we recorded above 80% of detention rates compared to traditional Braille using Braille devices. Our accuracy right now stands at a 97.3%ish, because the sensors which we use are very cumbersome. If we buy high-grade sensors, it's definitely improvable. But right now, the biggest bottleneck we are facing is the funding. So any funding we get from here will be directly supplied into the supply chain and production level, production.
And do you think about like monetization, or like how is it that you want to take it to market?
Yes, definitely. So currently our competitions are the traditional Braille keyboards, which have 6 prongs in total, like a traditional Braille cell, and they start from 45,000 onwards, and you can search it up. Our product right here, it costs us 9,700, and if I build it in bulk, I can create it within 7,200 to the dot. So it's a landslide price. You compare it with 45,000 to 7.2K. It's a landslide price, and we really believe we can scale over there. There's a huge gap in wearable haptics, and we are fixing that.
Thank you.
Jury members, if we have your permission, we can move to the next panel. I'll also request, for the ease of logistics, that the students who are presenting and are applicable for the query round, please come forward at the time of jury questions. We move to UI 10036, presentation number 5.
Hello.
I would also like to thank Deepak sir for his valuable time and for sitting through the first panel of presentations. Sir is unfortunately tied to another panel, but we have Dr. Anish with us, who will be representing the Atal Innovation Mission. Yes. Photography team, can we request for a group picture, please? Dr. Anish, please step back.
Shall you join us? Join us for the picture.
That's you.
Yeah, you should have some. So sorry for this.
They're doing such a nice job. Why not?
as a jury together.
Hello, good afternoon everyone. Let me begin. There are about 910 million population in India living in rural areas, out of which 65% of the people have lack of access towards the healthcare. These people faces shortage of specialists, and so they need to travel long distance, and also they need to sacrifice their daily wages. And also they don't have proper awareness about which doctor to consult and whether the doctor will be available at the location or not. In order to provide this information, several telemedicine platforms has been introduced, but it doesn't adapted among the rural areas. And this is the exact problem we are trying to solve with our solution. Medicare is a voice-enabled AI-powered telemedicine infrastructure platform. For this, you don't need to install any apps, or you don't need to open any website. You just need a basic feature phone. From that, you can able to call our agent, and our agent will perform an AI triage and gives awareness about whether the patient needs a doctor consultation or not, and also it says which doctor to consult, and it also calculates an urgency score. Based upon it, the doctor can able to easily prioritize the patient with high medical emergency, and also it books an appointment for the patient in the nearby location. Let us see how our solution works. First of all, the patient needs to visit the nearby public healthcare centers or pharmacies to make a call to our toll-free number. From there, our voice interactions are captured from Twilio and Fast API WebSockets, and those audio streams are sent to speech to text transcription, and those transcription are sent to our manager agent, which is powered by LangGraph, which orchestrates symptom analysis agent and booking agent. The symptom analysis agent works like it first extracts the symptoms from the user query using name entity recognition, which is done by bioclinical BERT, and from that symptoms, a semantic search is made into our vector database to ask relevant symptoms as a questions, and based on these questions are repeated. These questions are asked until and confidence in the urgency score is reached. Once the urgency score is calculated properly, the queries are redirected to the booking agent, and our booking agent will easily segregate the users whether they are having a life-threatening situation. If they are having life-threatening situation, their queries are handled to the ambulance, and for not life-threatening situation, it is handled in a smart priority queue, in which the patients are arranged in the order of their medical severity. And then for booking, based upon the agent will ask a PIN code from the user, and based upon the PIN code, it fetches the nearby hospitals, and it tells the patient, and from that the patient can able to easily book the appointment. We used MCP servers so that we can able to easily scale new tools into our infrastructure.
Let me explain the implementation plan of our solution. For pilot deployment, we chose semi-urban area with 10,000 users. Our estimation cost is around 40 to 45,000 per month. In rural area, our expected revenue streams are governmental sponsorships, CSR fundings, and hospital subscriptions. In rural areas, multilinguality provide a major impact. For providing that multilinguality call, it costs us around 2 rupees per minute. We assume that every patient will speak 3 to 5 minutes in that call, making it highly affordable. While expanding it across villages, we store the patient's conversation with their consents, and we fine-tune our model to make it more accurate. We designed our architecture to handle multiple calls concurrently. Let me show you a quick demo.
You can remove the message.
Hi, I would like to book an appointment with the doctor.
Please provide your 6-digit PIN code.
612004.
Please select a hospital ID 1, Fortis Healthcare 2, Apollo Hospitals.
1.
What date would you like to book for?
Today.
To confirm, the looking for hospital 1-20260216, say yes.
Yes.
Appointment booked successfully. Dr. Oscar Sanjay, give the date 20260216, token no. To appointment item, C4610 before 100 5 Magnus B3C.
As we can see that the patient can able to easily book the appointment and it is reflected into the doctor dashboard. Thank you.
Tech team, I'd request for mic access on the podium. Thank you, Aniket. Jury members, we now move to the next presentation, UI 23266. This is our young team from Thailand.
Right, so first of all, I would...
You can use the clicker on the left and right. You don't touch the screen. Sure. This is your presentation, right?
Yep.
How do you feel if your loved one was diagnosed with cervical cancer, a completely preventable disease? It's so sad that globally, over 300,000 women die each year. Why? Because women must wait up to 6 months, causing late prevention, leading to cancer and death. Yes, because cancer never waits. Cytoscan Z is the first innovation that protects your mother, sister, and loved ones from cervical cancer.
That was a short video of the summary of our problem and solution. Right, so we tested our system at 2 cancer centers in Thailand, which works in 3 simple steps. First of all, a cytologist inserts a slide into a Our Sigma eyepiece takes a picture of all the cells in the slide and uploads them into the website for another cytologist and the AI to do the analysis. Now, if the results are normal, the process ends immediately. Here is a video of us interviewing a negative patient. Now, if the case is abnormal, the case will be forwarded to a pathologist who then completes the diagnosis. Right, so as you can see here, our system has already completed the diagnosis, but the old system, the case still hasn't reached the first cytologist yet. From 6 months of waiting, women can receive the results in 1 day, which means they can have a chance to start treatment immediately. Right, so Cytoscan Z is fully scalable to over 162 countries because it uses an international data set. And we have also tested our system at 2 cancer centers in Thailand, and our workflow aligns with the WHO's goals and standards. Right now, our system has been copyrighted and patented, and has received support from both government institutions and businesses. And next, we plan to scale our system to be able to diagnose HPV-related cancers other than cervical cancer. And we also have a business plan that was created by discussing with the Northern Cancer Center in Thailand in order to reach 162 countries. And here is a video that shows our full expansion plan. First, we went to the Northern Cancer Center in Thailand to test and deploy our system. Next, we went to the Southern Cancer Center and tested our system there. Then then we would plan to expand our system to 5 more cancer centers and the National Cancer Institute in Thailand to protect 4 million lives. And finally, we will expand to 160 countries to protect 1.4 billion lives all around the world. Cytoscan-Z can reduce the waiting time for cervical cancer from 6 months to just 1 day, and reduces the cost of equipment by 5,000 times, making it accessible to most countries. And next, we will create the first cervical cancer data center to increase our AI's accuracy and teach future specialists. And Cytoscan-Z is environmentally sustainable because it is able to reduce transportation, and is socially sustainable because it can be used in all local hospitals. Finally, Cytoscan-Z aligns with the WHO's policies and is supported by government institutions, making it easily scalable.
And next is our demonstration. As you can see, this is our Sigma eyepiece, the automated microscope. By just add 3 pieces into the standard microscope that worldwide are using right now. Now, the standard microscope will turn to $1 million slide scanners. As you can see, we have two functions. First, the autofocus. Our algorithm will automatically focus. It will analyze the image, and now it will send the signal to the motors. And next is capture. By just one click, our Sigma eyepiece will automatically capture all the entire slice with our algorithms. It will capture for more than 360,000 images. And all the images will be sent into our web application. And here is our web application. As you can see, we can now upload the file, analyze it, and then the specialist can now easily diagnose it. That's it for our. Thank you.
Thank you, team. I'll request. Our next presentation is UI 22634. He's a 14-year-old young student from the United States, and he wasn't able to travel due to his midterm exams, so he has sent a pre-recorded presentation for the jury. Video team, please play presentation 7.
Hello, I'm Siddharth Nandiala. I'm 15 years old and I'm an entrepreneur here in Dallas, Texas. I'll start off with a little introduction about myself. I'm 15 years old and I'm currently in my first year engineering at the UT Dallas, where I was the youngest student ever admitted at just 14 years old. So I currently run a startup known as Circadian AI, where we use cardiovascular oscillation to detect diseases early. Essentially, just by placing your phone on your heart, in 7 seconds we can detect over 40 types of cardiovascular abnormalities. As we all know, cardiovascular diseases are the leading cause of death globally, accounting for 1/3 of all deaths, many of which could have been prevented if they were detected early. So what we do is we're essentially bridging that gap in identifying cardiovascular abnormalities efficiently and effectively by using a simple heart screening app. So we've recently conducted clinical trials on about 3,500 patients in government hospitals in Andhra Pradesh, GGH Guntur, GGH Vijayawada, and also GGH Paderu. And we did a double-blinded study where patients were randomly sent in who were high risk, who were normal patients, healthy patients, and also patients who were previously diagnosed with cardiovascular abnormalities. And we screened them all. Whoever was flagged as abnormal were immediately sent for a protocol designed by the Department of Medical Education, where they were sent for ECG, 2D echo, and then also cardiologist review. And also a random sample of healthy patients also went through the same protocol to evaluate the efficacy and the accuracy of the tool efficiently. So this led to us understanding how impactful this would be in low resource environments and also in extremely high volume environments. So in our testing, we found that this tool would be extremely useful in doing it in primary healthcare centers or providing it to nurses in government hospitals or in high volume home settings, because just in 7 seconds using an iPhone, we can detect various types of cardiovascular abnormalities. So this tool is incredibly scalable in what it is, because it's just a software that's running on an iPhone, and the only technology that it needs to run is an iPhone itself and the microphone on an iPhone. So it's incredibly scalable, and it's incredibly useful in being able to identify cardiovascular abnormalities early, which is what we're really trying to do here at Circadian AI. So here's a quick demo of the app on an iPhone. So all you do is you take it and you place it on your chest like this, and then you record it for 7 seconds. Perfect, and it's just given an audio recording that you'll be able to hear. Like that, of the heartbeat sound. And then you click the analyze button, and then it'll give the result, in this case, healthy heart. Finally, I wanted to thank you for your time and consideration of Circadian AI. We're building the future of heart health technology, one heartbeat at a time. Before I end off my presentation, I wanted to give my sincere thankfulness for the jury and their consideration of Circadian AI. I wanted to apologize for not being able to be there in New Delhi right now today, presenting live in front of you. Unfortunately, because I am in college at just 15 years old, it does come with its own unique constraints and challenges. Currently, I am in the process of studying and doing my midterm exams in my college, so it becomes a little bit difficult to travel to New Delhi at this time. However, I am very happy that I've had an opportunity to participate in this challenge, and I hope to bring Circadian AI into the use case of innovations and integrations in hospitals, primary healthcare centers around the globe. Thank you.
Jury members, we have UI 3536. Rishi. Is team 3536 in the hall? Are you ready to present, or would you like to present later? Okay, no worries. Jury members, we're open for Q&A round for the teams that have presented so far. 10036, 23266. Siddharth unfortunately won't be available for the Q&A round. The teams are here.
Okay, I can go first. So for the team that was doing the cyto scan, I guess my big question that I did not really understand through your presentation is, what is your innovation? Right? Like, what are you doing differently than others in the space?
So basically we have a completely full system, while other commercial scanners or alternatives, they just merely scan slides. But for us, we have a system from image collection and cell imaging to AI analysis and sending it and transportation. Right. So yes.
What prevents the others who are in the space and already solving it from doing the same thing that you are doing?
With our AI, so normal AI that globally worldwide are using it right now. So they are just put data set in the AI, and the AI.
Right, so the images are just inputted into the AI and it just analyzes, that's all. But for us, we have we use a multi-model AI system which has like an entire process through in its analysis. First, it does some object detections and then crops out the individual cells, and then it's segmented by a unit segmentation model, and then the pixels in each organelle are counted and are calculated in a mathematical formula, which that formula is what we use to classify the abnormalities.
Thank you.
So I have a question to this 10036. You're here, okay. So the question is, so who are your target, these customers or beneficiaries? And do you think how feasible is it for the rural people to adopt this technology?
Sir, this is for actually rural patients, and rural patients, I have brought up in rural areas. So I saw many rural peoples can't able to access the modern platforms. So my idea is to, using their tech itself, what are the technology they are using, from to it we are bridging into modern infrastructure, so that they can able to easily access our services through mobile phone.
But the question is, how do you think is it feasible for them to adopt this technology?
They just need to call, and our agent will take care of their queries, and they can able to it's like a communication with a health worker, like that only.
Okay.
Are there any language barriers you're anticipating?
Yes, ma'am. Currently, we have created for English only, and also we are adopting for multilingual support, so that the rural patient can able to easily access.
So basically, see, when we talk about rural India and we talk about reach in rural India, we are talking about a massive country, many dialects, many languages, right? So that's an added complexity in this. So keeping that in mind, if I were to compare it with, let's say Manipal Hospital, they use an app for booking. It's a very simple app. All you need is you download the app and you know, they ask for an OTP, you do that, that's about it, and you choose the doctor that you want to meet. So the question is, would that interactivity be easier or would this be easier? Both might come with their challenges, but at this point in time, which interactivity would be easier?
That would be better if they have smartphones, but in several rural areas, they don't have smartphone and internet access. So that using our platform, they can able to easily call and book their appointments, so that many people can able to avail the medical services.
Got that. But your language consideration still remains,
Yes.
and
So
that's the
for-
scalability aspect that you need to think about.
So for that, while we are scaling, we will store the conversation of the patient with their consent, and we will retrain the speech to text and text to speech models, so that the language and dialects will scale while we expand across villages.
Sure. Thank you.
My question was the same about data privacy. When you're speaking to someone on the phone, taking their information, their data, how do you think you can mitigate that risk, because data privacy laws are being stricter and stricter now as we go ahead?
So, can you repeat the question, please?
So, when you're taking patient's data, so when they're telling you what symptoms they have, you are basically mediating an appointment for them as well. So, you're taking their data as well. Like you said, you will actually store the data and try to learn on that data as well. How do you then actually comply with the data privacy for the patients as well?
So, first of all, we will be isolating each user's conversation, and also we are storing with their consent, but we don't store their personal details like their name, ages, or phone number. We will be allocating a stream ID. For each call, there will be an ID, and for that ID, those conversations will be recorded, so that those data won't be explicitly given to anybody.
Thank you.
Thank you, jury members. Thank you, team. We now move to third panel for the day. It's the 8th presentation, UI 22861. Do we have a
Hi judges, do you ever hear about malaria? Malaria is a disease that kills one life every 50 seconds. Why? Why can't we eliminate malaria yet? It's a question in my head. The problem because one, right now we always react instead of prevent. Example, NASA system, they're using statistic data that not real time. With the big scale of province scale, that make the system of preventing is not accurate and cannot use in the real field. That's why the world needs malaria, the first ever forecasting. That is solution one, that forecast malaria before the epidemic. And two, the problem of right now, because in rural area, we have only these two, RDT, rapid test kit, that can only access the rural area. But the problem is, malaria is the disease that have different of species, over 5 species. And all 5 species have a difference of treatment. So that's why the positive or negative result, it's not have any meaning in there. So that's why we have to create the first portable microscope with diagnosis AI. Xscope rapid site 2 with Malasite will change and break through this. And this is the video of our innovation solution.
The end-to-end malaria elimination system.
The audio sound, please.
With our predictive response.
Audio. So this is the video showing our system using in the real place. No, this one. Yes, this. Okay. The sound of video.
Of this video.
Yes.
Play the video on the slide.
Malaria X.
Okay, so this video will talk about the Malaria X, our system that already used and deployed in the real field test. Right now in the video, I will show that. Yes, our Malaria X system is we have 3 parts. Before, we predict the risk area that will outbreak in our website there. And after that, when you know that outbreak took place, we will go into the field in just 2 hours. And during we getting into the field test, into the field, rural area, we will use our Xscope rapid site or our system to diagnose malaria and give a patient correct treatment. And after that, this is the patient that using all our system. And next, right now, we already scalability around 3 centers in Thailand. First, at the Northern Disease Control Center in Chiang Mai, we deploy Xscope rapid site in Mala site. And next, 2 weeks, we go to Thar province, Thailand, to test all our system there. And after that, we go to the southern part of Thailand to diagnose and test our system with a special case of malaria there. So that's why right now we already deployed to around 10 centers in Thailand. In 3 months, we already take care about 260 cases of patients. And for sustainable, Malaria X, it's not just the best innovation, because Malaria X no need to use experts or the specialists, because all our system can use by just normal people like you. All of you guys can use our system by just training in 1 day. You can be like specialists in the rural area. That's why people in the rural area can get the correct treatment and like having the experts in their place and can access all of the gold standard treatment. And next is our demonstrator. I will show you our website of using our MalaTrack system. In this, you will see that this is the screen of our officers' centers. Hey, we'll see. The first step, scenario 1. When the place in the map have the outbreaks, it will alert to the system. When it alerts, it will show the screen that how to adjust at that place. Because our simulations will recommend how to adjust the place outbreak if you click scenario 1, if you click the adjust outbreak and it's not working, they will recommend another adjust way for the best method to prevent malaria before the outbreaks, epidemic, right? And next is our demonstration of Malasite.
And I'm proud to present the Xscope rapid a portable microscope. And this can be used in 3 systems. Step 1, we have to use
don't leave someone behind. We detect to protect. Zero Maria, start now.
Thank you.
Can I just get one question?
Expert. Thank you.
Thank you.
Thank you, team, for an enthusiastic presentation. We move to the 9th presentation for the day, UI 13482. Jury members, this is UI 13482.
Good afternoon, judges. My name is Shiroshi and I am the co-founder of Voxit, which is basically voice-based observation using explainable AI for dysarthria. At first, let's understand what is dysarthria. Dysarthria is basically a neurological speech disorder which is caused when the important parts of brain such as motor cortex, cerebellum and the brainstem got damaged. As a result, the speech muscles becomes very weak and the speech become very slurred and the people are unable to talk. Then it is not only a neurological speech disorder but also an early sign for serious diseases such as stroke and Parkinson's disease, which can cause a lifetime burden for a person. If we see the worldwide dysarthria affected rate in the world, it is about 0.1 to 0.5% of the total population, and in India it is about 0.5 to 0.6%. The long-term effects of dysarthria can be permanent speech loss and the swelling effects and can cause a lifelong medical burden for a person. The main problem of the dysarthria detection is the early detection. It cannot be early detected because the early symptoms of dysarthria is very much unclear and unnoticed, is very much subtle. The people cannot understand they are suffering from dysarthria, and mainly the rural people can't get access to the costly tools and the specialist help. As a result, they remain undiagnosed or get diagnosed at the very large stage when they are unable to cure themselves. So we are building an easily accessible, affordable AI-powered screening tool for dysarthria detection. At first, let's understand then what is Voxit. Voxit is basically an AI-powered screening tool that enables early detection of dysarthria by analyzing the speech patterns and generating an explainable report, medical report within seconds. At first, we have trained our model using 2,000 open source voice samples, among which 500 male dysarthic and 500 male non-dysarthic, same for female 500 male dysarthic and non-dysarthic. Then we have sampled the voice at 16 kilohertz in order to extract the important features such as MFCC, ZCR, zero crossing rate, and the delta and delta 2 in order to extract the most important features that are responsible for dysarthria. Then we have passed it to the CNN model in order to analyze and predict the speech patterns. Then the most important innovative part of our project is that we are not just predicting, we also explaining for which features it is dysarthic, and we also showing the feature level analysis. That's why the model is predicting it dysarthic. And our model accuracy is about 94% or above and with low latency. And this is our software design we have made. This is a very working model where the user can log in themselves and then they can record or upload a short voice sample. Then the voice will be analyzed and the result will be shown. If it is dysarthic or normal, then our automatic PDF generation report option will be there, which will tell them for which reason it is dysarthic, or if it is normal then okay. And if it is dysarthic, then it will tell them for which reason it is dysarthic and what precautions they should take. At first, the real and the market impact of our project is that we are aiming to collaborate with the hospitals, old age homes for the early and the regular screening of the person. Then the user can screen themselves through their mobile phones from anywhere throughout the world. And the people, we can also use this in NGO and health plans for the early screening. And the most important focus of our project is the rural people. Rural people can't get access to the costly tools and the specialist help. As a result, we are focusing on them and want to build our main support is the Ayushman Bharat, which mainly focuses on the development of the rural people healthcare. So we are aiming to affordable hardware which will be available at the rural diagnostic centers for their easy and affordable screening. People can usually go there at an affordable rate. They can screen themselves and understand whether they are dysarthric or not. If they are dysarthric, then they can perform further screening and go to the cities for the further help. And the most important thing, the rural people cannot give doctor visit every time. It is very much expensive. So they let the omit the suspicious. As a result, they cure themselves at a very large scale, but it is not at all curable. And we also building an smart reference system. If a person is detected dysarthric, then the app will suggest them at what they should do and what hospital they should visit and what specialist help they should take. Our business model is B2B. We want to collaborate with the NGOs, hospitals and the rural development program for the development of the rural people. We also aiming for the multi-regular activity which is not available in India, and our project is different from the other projects because it is very much affordable and early screening detection is done and the people can easily access themselves through their phone also. We also tell that Voxit doesn't replace doctors, it helps the people to reach doctors at the right time. Thank you.
Thank you, team. We now move to the 10th presentation for the day, UI 21582.
Yeah.
Oh, is that okay?
Okay, I will start with สวัสดีจ้าเจ้านายจ๋า Okay, first, so okay, never mind that. So in our world, there will be one disease that everybody and everyone should care about. It is about Alzheimer. So imagine you wake up one day, but your grandfather, your father, your mother forgotten you. This is not because they stop loving you, but because of Alzheimer disease. And you know what? Alzheimer disease already killed 1.8 million people a year. That's a big number. And this comes with three major problems. One is Alzheimer disease will be 139 million people by 2015. And two, lack of doctor. One specialist has to carry about 375 patients. And three, for diagnosis and treatment, it's cost over $100,000 US. So Alzheimer has different stages and each stage need different treatment. So as you can see, in early stage, Alzheimer didn't show up and can be seen. So Index created the first ever AI model to convert video to screening. And in the first stage and to middle stage, Index created the first ever sonography therapy VR headset that you can buy it a bit under $50 and that's simulate the VR that help you. And in last stage, you gonna be die absolutely. So we want you to have a happy memory before you die. So what makes your Index unique? So Index is in all-in-one solution, can be prevent, treatment, and also screening. And this can be solved that it can be accessed anywhere in the world. And two, it has personalized AI. And three, it's only $50 or 2,000% cheaper. So what made this feasibility? So we didn't change how doctors work, but we implement them, make them work easily. And you can see that we also implement Open Cloud, the new thing that just come out like 2 weeks ago. Then we also have a copyright. Let me bring it out. So here is our copyright, and also we do it under human ethical, and also be in the clinic usage with real user. So how do we distribute this? So first of all, the main target of my project is doctor and partner. So they will get sharing profit from their putting in clinic or nursery home. And then in the secondary target is the Department of Health. So they will distribute in hospital in Thailand. So we're using copy and paste clinic playbook. So we will pilot in one to two pilot clinic. And then if that work, if that strategy work, we will implement it into other client clinic. And we will do it in 3 phases. So in phase 1, we will validate it first, then test it with some small target group, and then we will globally scale it. And what makes it scalable? So we have 2 layers of architecture. So one is auto load balance, so it can handle 10,000 people. And 2, data layer, all data are encrypted and we all private. And 3, we using all third-party platforms, so anyone can access it. So this is architecture. So when somebody, some patient have to do it, and then we will get more user. More user mean more data. More data mean more accuracy. So more accuracy, then there will be more user again, and we get our ecosystem and community. Okay, now how we win. This is my 4 win. So first of all, customer will get all-in-one platform with a cheaper price at only $50. And 2, hospital will get customer from us, and then they will get the sharing profit when they bring their customer to us. And 3, government will reduce financial burden, reduce debt rate, and increase quality of life in the country. And lastly, India will get more users and also more money. So here's demo. So this is the demo of screening to video to screening. So I upload the video of footage. This is about 5 minutes, and this will analyze as the video and show that what part of the video are dangerous and have a risk of Alzheimer. This accurate 97%. And another one is this VR. This VR also generate a map and a world for Alzheimer patient individually. Okay, I think that's all for me. Thank you.
Thank you, teams. Judges, we are open for queries for UI 2361, 13482, and 2582. The teams are seated on the right.
Yeah, I have a question to this 13482. Okay, so you have developed the technology, right? So how accurate is it, and how do you validate that accuracy?
So we have tested it with many peoples, and since we are students, we have tested among many friends, among around 100 people. We have tested with their voice, and since we don't have any dysarthric people, we are uploading our dysarthric voice, and if you are recording a normal voice, it is showing normal, and with a confidence score is also showing.
So you haven't tested with the real affected people, or?
No, so we have tested it with the open source voices we have downloaded, which are available easily from some hospital websites, or which are easily available. We have tested with that only.
Okay, fine.
My comment would be Paraspeak and Voxage should possibly collaborate to build on this further. That's my comment. But thank you. I really like the problem statement that both of you took up.
And thank you to all the 3 teams who presented.
Teams, we'll be taking a 5-minute break for the jury members, and then we'll be back again for the 11th presentation. Thank you. I request all the guests who are keen to see more student presentations to stay in the room, and please be back in the next 5 minutes. Something to stand on. Oh my God, this is going to be a hard challenge.
Time after the event, I just want to talk with you.